Alright YouTube, hello, thank you for watching. Today playing with a flyback oscillator. I've been making these off and on for about 3.5 decades. I haven't got them down to a science yet, although in recent years I've gotten a little bit closer. If I could get this up to 16 volts, they really start to come alive, at least this one does. It's drawing about 16 amps. It's not burning very hot, and you can always kind of tell by the sound of the plasma really how hot it is. So I'm not sure if my Astron's gonna shit the bed on me or not. I'm kind of pushing the threshold here. I don't have a 30 amp meter anymore. I did blow this Astron one time before on this. 16.4 volts. Getting some high voltage leakage from somewhere. Definitely smelling a burning clip lead. I have two 15 amp fuses on the secondary of the transformer, which is a bit unconventional. And anytime you parallel fuses, you never know what to expect because one fuse always hogs more current than the other one. So I mean, with two 15 amp fuses in parallel, you can blow one fuse and then blow both fuses by merely drawing 20 amps off of it. It's possible, but I know we're over 20 amps for sure. These flyback converters are quite sensitive to voltage. Putting 12 volts in is a significant difference than putting 14 volts into it. So as you bring the voltage up, you can get a lot hotter plasma out of them. These 5886's TO3s are as good as any transistor I've ever found. You could probably try running this on some 2N5039s if you wanted to build something like this. I would try to stay away from 3055s. That's going to be about the only TO3 transistors I would even mess with in this. Definitely getting some leakage somewhere. These flybacks are really good. It wouldn't be leakage coming out of the flyback itself, but there could be some leakage coming out of these terminals on the other side. Or I could be hearing leakage across here maybe. I'm not going to push this Astron because I'm kind of on the ratty edge with this power supply. As hard as transistors are to get today, it would be a foolish thing to do, because I can pretty much tell you right off the bat, if you buy a TO3 transistor on eBay, you're guaranteed to get a piece of junk that's going to burn open the first time you use it. Well, I don't want to say you're guaranteed. You got to watch who you buy from. You know, if you see large quantities of TO3 transistors, is pretty much what I want to say, you can be guaranteed they're fake. Whether they're coming from the United States or China, it doesn't matter. If you see somebody that's offering a whole pile of them, now if you find an American seller, you know, that's selling 2, 3, 4, 5 of them in a clip, you know, you just got to watch your P's and Q's. I'm kind of getting off the subject here. But anyway, it's ugly. That's just the way I kind of had to kludge it together there. You know, you got to keep the wires as short as possible. I mean, you can't be running primary wires all over the place. So everything had to be close to the heat sink as possible. That was really the only way to do it. There's some turn-off snubbers on here. There are two 7.5 ohm 5-watt resistors in series. There's a 022, although 022 isn't really much of a snubber. On this one, an 047 would actually work better. And then there's a fast 3 amp diode in there. That kills the turn-off spike on the collector of the transistor, which can get pretty high. These transistors deal with that very well. Honestly, it wouldn't have surprised me if I'd have put the scope on it and seen 180 volt spikes on the collectors. These transistors do well with it. The pulse duration is pretty narrow, but you know, if you did that with some other semiconductors of today, they just simply wouldn't last. You know, these old school TO3 transistors, you can't beat them. The saturation voltage on them is pretty incredible. That's the whole key to getting power out of these things. If the saturation voltage on the transistor isn't low enough, you're going to lose a shit pile of power. I've tried making these with IGBTs, and I'll tell you what, it was just a complete waste of time. If you wanted to make these, find yourself a real good low saturation, high speed TO3 NPN switching transistor. That's really the best I could tell you. They're super cool to build. There's 8 turns of Litz wire, number 16 center tapped, and there's 2 separate primary windings on this one. So there's an end, 4 turns, tap, 4 turns, and an end 2 times. There's 2 layers of 16, and you see both ends come back and get tied back to the collectors, which are tied together. Same way over here, the 2 primary ends come down and tie on to both the collectors that are tied together down there. And then the base drive windings are double duty too on this. I just tried this as a experiment to see if this would even work. I had concerns about the coils bucking, but that doesn't happen. So there's actually 2 individual base windings too. There's end, 2 turns, tap, 2 turns, end, and then there's another layer of base drive over top of that, the same identical thing. It's almost like building 2 individual oscillators, but they're all on the same core. It's kind of freaky that it even works. And then up here there's 2 resistors to start the oscillation, which tie to the center taps of the base drive windings. Both base drive windings come back and tie together. And then there's a 100 ohm 10 watt here. And then there's a, I think this is a 10. Yeah, that's a 10. So these bias resistors basically just start the oscillation and keep it oscillating. Like I said, not much to it. You know, these always oscillate. The only way this thing would not oscillate is if you would reverse the base windings and end up having the base windings in phase with the primary. They're pretty foolproof. If it doesn't oscillate, you just flip the ends of the base drive windings from one transistor to the other, and boom, there you go. Now I used Litz wire on this, but I'll tell you what, from years of experience, you know, I wouldn't even waste my time using Litz wire on one of these anymore. I just did this just to see if anything was going to change. And I think honestly, this piece of number 14 Belden wire at the frequencies at least that this one is running would work just as well as what the Litz wire on there does. I would just wind the primary with some 14 gauge magnet wire. I think the Litz wire would probably come into play at much higher frequencies, but these generally run 20, 25, maybe 30 kilohertz at most. The Litz wire really isn't advantageous, I'd say. But anyway, hey, thanks for watching my video. You take care and have a great day.